We want to know, what does the derivative tell us about the shape of our graph? So if this is the original graph, and I drew in some tangent lines here, what do these first three lines all have in common? They're going up, so their slope is maybe increasing, but at least a positive number, right? They all have a positive slope. What about these? Negative slope. These, positive slope. So if the tangent lines have a positive slope, when, or what does that tell us about the graph? We had positive slopes here and here. What's happening on the original function on those two? It's increasing. When the tangents were negative, the graph was decreasing. All right, so that's the first connection, the increasing, decreasing test. If the derivative is positive, the function's increasing. So in your blank, you could say f is increasing. If the derivative is negative, f is decreasing. So let's look at a problem. Where is this function increasing and decreasing? So first we would do our derivative. That's our derivative. Those critical points. Look back at our graph. When it switched from increasing and decreasing, that happened at point B and point C. B and C were what? Yes, it was when the tangent was 0. So those were our maximums or minimum points. So when our derivative is 0. So to find out when we switch from increasing and decreasing, or vice versa, we have to first find out when our derivative is 0. What's another name for those points when the derivative is 0? Critical points. So we're finding our critical points. So my critical point is 2. That means 2 might be a maximum, it might be a minimum. All right, I don't have a specific interval, so I can't test it that way. What we're going to do is make a sine line. Do you remember doing these like for some of our rational inequalities before? So we put our points when it's equal to 0. So that's at 2. And then we do our test points. Something smaller than 2 and something bigger than 2. All right, so if I put in a 1 and we're putting it into this derivative. So if I put in a 1, 2 minus 4 is negative. If I put in a 3, 6 minus 4 is positive. So the graph was negative before 2, so what does that tell me was happening? Decreasing. So it's decreasing, we'll give an interval, so from negative infinity to 2. And it's increasing after that because the derivative is positive, so increasing 2 to infinity. So if I want to know increasing, decreasing, we have to start with our derivative and find our critical points. So finding out when our derivative is 0. So we get 12x cubed minus 12x squared minus 24x. All right, if I set that equal to 0, what would you do first? Take out a 12x. And that factors into its minus 2, x plus 1. We set those equal to 0. So if 12x equals 0, that means x is 0. If x minus 2 equals 0, that gives us a 2. And if x plus 1 equals 0, that's a negative 1. So we have 3 criticals, negative 1, 0, and 2. All right, we need test points, so something smaller than negative 1, negative 2, in between negative 1 and 0, maybe negative 1 half, in between 0 and 2, so maybe a 1, and bigger than 2, so maybe a 3. And we are plugging these in to the derivative to see if the derivative is positive or negative. Now you can do it here. It might even be easiest to do it in the factored form if you don't want to rely on your calculator as much. Like when I put in, if I put it into my factored form, a negative 2. 12 times negative 2 is negative. Negative 2 minus 2 is negative. Negative 2 plus 1 is negative. If you have 3 negatives, your answer is negative. If you put in 1 half. 12 times negative 1 half is negative. Negative 1 half minus 2 is negative. Negative 1 half plus 1 is positive. So that section is positive. If I put in a 1, 12 times 1 is positive. 1 minus 2 is negative. 1 plus 1 is positive. That's negative. Put in a 3, we get a positive times a positive times a positive. So positive. These all alternate signs, they don't have to. Most of the time they will. But there are some instances where they won't. For instance, like x cubed. Okay, if you take the derivative, you get 3x squared. When does that equal 0? At 0. But isn't x cubed decreasing both before 0 and after 0? Yes. So don't just do the first one and assume they'll alternate signs. Make sure they do. So where is this one increasing? And good. Where is this one decreasing? Is that okay? Now, what if I want to know about my local maxes and mins? We said critical points are where you can have local maximums and minimums, but we've only actually found the absolute from them because we could actually compare those y values. If your graph is decreasing and then it switches to increasing, what just happened? Is that a max or a min? A min. If your graph was increasing, but then it switched to decreasing, what did we just have? A max. So we can actually tell from the sign line if things are maximums or minimums. So that's the first derivative test. Okay, you have to have your critical numbers. If the derivative changes from positive to negative, that means it was increasing and it switches to decreasing. Then you have a local maximum at that point. If it changes from negative to positive, so decreasing to increasing, that's a local minimum. If it doesn't change sign, then it's neither one. So no local max or min. Let's look at a couple examples of that. So if I wanted you to find the local maximum and minimum values of this function. What do we have to do first? Derivative. Oh, wait, was this the same function as we just did? Yeah, sorry, this is just continued from example 2. So we don't have to redo it all. I was just going to have you take what we had done and tell me what our maximums and minimums were. So, based off what we just found, where is my local max? 0. We need to either give an ordered pair or you can put it in function notation. So 0 was the x, but I need to find my y value. To do that, you want the y on the original graph, so you're going to plug 0 into the original function. So if I put 0 in for all of those, we just get 5. So f of 0 equals 5, or if you wrote an ordered pair 0, 5. That's 5. Okay, my other critical points. So at -1, we went from decreasing to increasing, and that created a local min. So you can write an ordered pair or function notation, I don't care. But to get the y, we have to plug -1 into the original function. So -1 to the 4th would be 1. -1 cubed is -1. 12 times -1 squared is 1, plus 5. 3 plus 4 minus 12 plus 5 would get 0. And we had one other critical point at 2. So before 2 we were decreasing, after 2 we are increasing. If you go decreasing to increasing, which one is that? A min. So it's a local min. We're not finding the absolute because I don't have endpoints. So just the locals. So if I put a 2 in, I get 48 minus 32. -27? Not one of you even tried to calculate it.
I was trying to in my head.
Are you starting to see why I told you it gets harder and harder for me to make tests with nice numbers? Like, you have to have nice critical points and nice y values when you plug them in. And soon we'll start doing the second derivative and finding when it's 0. And it gets hard to make all beautiful numbers. So expect to use calculators on your homework. I don't put the brain effort into trying to make those pretty. Is that one okay? All right, let's do example 4. So I want to find and classify the critical points. So to do this, we're first going to do our derivative and figure out increasing and decreasing. So 6x squared minus 6x minus 36. I need to know when that's 0, so we could take out a GCF. That would factor into x minus 3, x plus 2. We set those equal to 0. We get 3 and -2. These are the critical points. All right. I asked you to find if they were maximums or minimums, but to do that, we really need to know if it's increasing or decreasing. So we put those on our sign line. And then we need our test points. So smaller than -2, in between -2 and 3, and bigger than 3. Right, if I put in a -3, 6 is just a positive number. I don't have to worry about that. -3 minus 3 is negative. -3 plus 2 is negative. If I multiply 2 negatives, if I put in a 0, I have a positive times a negative times a positive, which is negative. If I put in a 4, positive, positive, positive is positive. I didn't ask for it, but if I wanted to know, where is this graph increasing? Mm-hmm. And? Good. You wouldn't have to write that down in this question, but it's good practice. Where is this graph decreasing? What I asked for were the local max and min. Okay, so it starts out, this graph was increasing and then it switched to decreasing. So at -2, we have a max. You're welcome to write an ordered pair or function notation. To get the y, though, you do have to plug it back into the original. What's going to happen if you plug it into the derivative? You'll get 0. We've already found this point when the derivative is 0. Okay, so if I put -2 in, $51, maybe? Do you guys know how I'm getting the y values? Yeah. Oh, yes. All right, my other critical point was 3. At 3, we went from decreasing to increasing. So what's that one? A min. So when I put in 3, we get thank you. It's almost there. It's down to -81 plus stuff. Okay. Is this okay? I think I want to stop here today. I want to let you guys practice this because everything that we do just keeps building in this section. So I want to make sure we're good with one thing before we move on to the next. I have a hand